Hi, I'm Sidney Eisner, SolidCAM's Vice President for Quality Assurance. Today, I will be showing you the new coordinate system. But before I do that, let's first discuss why we needed to enhance our old one. Was it really inadequate? Was it missing functionality? Did we just want to give it a pretty face? Well, I can answer that first one easily. No, it was not really inadequate. It has served its purpose for many years, and we were always able to produce the coordinate system exactly where you wanted it. But as SolidCAM became more advanced and more powerful, we needed to keep up with the changes in order to accommodate our customer needs when working with the coordinate system. This included full associativity, more flexible editing capabilities, easier to use, and more visibility. Now, let's take a look at the issues we needed to address. Upon creating your coordinate system, once you accepted it, that was it. It stayed in that place without any physical regard to the actual part. If the part was changed and the location origin or the angle of the coordinate direction changed, the original coordinate system would stay in its original position. This forced you to edit your original coordinate system. And then, when it came to your coordinate system levels page, there was not any option for associativity as well. And then, there's also no visibility. You did not have any indication of what faces or points you used to create your coordinate system or where your levels were located. Now, speaking of editing, that in itself was another issue. Since you accepted the coordinate system beforehand, any slight change you would want to do would require you to redefine the coordinate system from scratch. The list can go on. Now, in the new coordinate system, we have addressed all of these issues, such as associative fields, visibility, automatic origin location, and more, including some surprise enhancements we've added in our levels page of the coordinate system. Well, we always say that seeing is believing. So let's take a look and see exactly what we have done. Now, I've loaded this part in particular. It's an assembly part. And I've already taken the liberty of putting it inside SolidCAM, ready for our coordinate system. Now, I already have it here with the clamps because there's some features I'd like to show you as we're working on it with the clamps itself. So if I were to go into my coordinate system, the first thing you'll notice is very simple. All of these fields that we see over here, every single one of them are now associative fields, whether it be the Z direction, the XY direction, the origins. Every single one of these fields are now associative with associative fields. And we've also added one nice little option. If you look over here, it says Auto Location Top. What does that mean? Say, for example, I were to click on this surface over here. Well, what would happen with the auto location top, it'll automatically go to the closest hot point on the top of the part, closest corner over there. Okay? Normally beforehand, you didn't have all these choices. If you had a choice, maybe it came to there, maybe it came to the center of the box, but you were not able to bring it to the closest point. Now you can. You can also see the associative field, as I show you over here. Now, this is not only on surfaces, but if I were to, for example, click on the cylinder over here, it would put it at the center of that cylinder, just exactly where you see it right now. If I were to click on this surface, just go back to this field and click on this surface over here, you'll see that it'll go to that top surface at the corner, just like I put it before. Just over there. Now, I'm going to put it back right now in this corner over here, as I mentioned before, just like I started out with doing. Now, you'll note that it will automatically jump down to our XY direction. And right now it says automatic because that's the automatic direction that we get from a coordinate system in SolidWorks from their sketch plane. Okay, I can leave it like that, but I always like to give it a specific direction, and I'll explain about this why a little later. Just for now, I'm going to just click on the surface. By the way, now you can also click on the surface, and you can get your direction. Now, as you go further down, you already see that my pick origin has something in it. My pick origin says it's on an automatic point. Remember, this box is an automatic box. Okay, that means that it's not the part itself, but this box will always follow the actual part itself. And it's attached right now to the box. Okay. Now I'm going to actually make a little change on my pick XY origin. And for that, I'm going to use my cylinder over here. I'll just click on the cylinder, and my XY origin will now be at the center of that cylinder. Okay? You'll also note that if I go further down, my pick Z level is on automatic because it's still attached to the automatic level of the box itself. Now, by the way, this field over here, the pick Z level, is completely new also. If I, for example, wanted to put my Z level on, say, this surface over here, what did I used to have to do before? I used to have to first measure what's the distance between here, this surface, and this surface over here. And then I'd have to go further down in my modify Z level and put the value in over here. But now we can actually go into this field over here, this new field, and just click on that surface. And the coordinate system will automatically jump down to that level as shown over there. Okay, you can see it's on that level. Now, I'm going to continue with my levels page, as we see over here. Now, you'll also note that we have some changes in our levels page. Our levels page is now also completely associative. For example, my clearance level. I have no idea how high this is right over, how tall my clamp is, how much I want to go over it. Oh, I know how much I want to go over it, but I don't know what the level is itself. So if I go into my clearance level, I can just click at the top of the clamp, and it'll put that value in here automatically. And then I can say, I want to go with a delta value, let's say 10 millimeters above that. And there it is, 10 millimeters above that. My upper level, I can just click on the top surface of the part itself, and there we have our upper level. Same thing with the lower level. Lower level, I can go in here and say, click on this point over here. You can see the associativity of that lower level, and I can even give that a delta, say, of minus 6 millimeters. Note also when I go into these fields, you can see exactly what fields I chose. It's all visible. This is what I meant by visibility. Okay, I'm going to accept this. And now it actually takes us into our coordinate system manager. And if you note in our coordinate system manager itself, we also have our clearance level. If I click on the clearance level, it shows you the actual clearance level, including the delta value that I gave of 10 millimeters. My upper level, lower level, including the 6 millimeters that I put at the very bottom. Now, I'm going to accept this. And after I accept this, I'm going to make a couple of changes. Now, when we get to the CAD manager, I'm about ready to set up my work. And the first thing I'm going to do is I'm going to walk through my tool shop, and I'm going to start looking for the clamps that I need for this particular clamp. Now, as I'm going through the tool shop, I find that, let me open up this clamp for a moment. And I'm looking for a clamp, if I click on this over here, that is 15 millimeters thickness. Well, I'm looking, and all of them have been used in my tool shop. And the only ones available to me right now are 25 millimeters. So I'm going to change this now to 25 millimeters. And of course, we're going to exit and save it. And now let's take a look at our actual coordinate system over here. You'll note that is asking me to synchronize. Now, if I right-click and go ahead and synchronize, and I go back into my coordinate system manager, let's take a look at the edit field. And we can see now that instead of 55, what I had before, I now have 65. You can see the associativity right then and there. Okay. Now, we always know that engineers, when they design a part, there's always something called a revision. Okay? Now, the engineer came over to me, and he said, we need to make a revision. What's the revision that I need to make? You see this step over here? It's 10 millimeters. The revision is that we need to make it now, not 10, but we need to make it 20 millimeters. Okay, so I'll make it 20 millimeters, and it grew. Okay, we're going to save that. And again, we come over here, we see that it needs to be synchronized. Synchronize it. Go back into our coordinate system manager, go into our edit, and you can see the values have changed here again. Again, my clearance level now jumped up to 75 millimeters. And of course, my upper level, instead of being 40, what it was before, is now 50 millimeters. Now, there was one more revision that I was asked to do on this part. What was the revision? This particular cylinder had to be moved by a few millimeters over to the right. So if I go into my part itself, I'm going to do just that. I'm going to edit the part. And if I were to go to that cylinder, you'll note that it is right now at 25 millimeters distance from this wall, the axis of that. I'm going to change that, as per requested by the engineer. I'm going to change that to 28 millimeters, okay? You can see that it moved over. Again, I will accept what I've done over here. Now, let's put this in the top view. If I put this in the top view, what you'll see is as follows. The coordinate system is not exactly in its place yet. Okay? This is exactly where it was, and this is where the new location is supposed to be, in the center of that. If I go over here, you'll see it needs to be synchronized. When I synchronize it, you'll note it'll automatically update its location to be in the center of that cylinder. Now, what I'd like to do is I'd like to close this part, and I'd like to open up another part to show you some more of the functionalities that we have inside the coordinate system itself. So I'm going to open up a part that looks very similar to what I've done before, but there are certain catches to this. For example, if I were to take a look at the top view, it may be hard to see, but I'll explain to you as I go along. This part itself is rectangular, perfect rectangular. However, it's lying on the SolidWorks coordinate system at a 0.3 degree angle. It's not exactly straight. It may have been created inside some kind of assembly of some sort, and this positioned assembly was 0.3 degrees. Okay, that's the way it was designed. I can't do anything about that. So let's start now with a new milling project. And when we get to our coordinate system, we'll do exactly what we did before when it comes to the coordinate system itself. Okay, we'll start off with the coordinate system, and I'm going to put it on this particular surface over here. Now, right now, it really looks great, but let's take a look at the top view. Okay, if we take a look at our box, you can see that our box doesn't line up with our part, because our part is at a 0.3 degree angle. The box itself is just the outside boundary in the XY direction. Now, remember I told you before about why it's important to pick the X or Y direction? Well, that's exactly what I'm going to do right now. If I pick now, let's say, my X direction on this surface over here, and let's take a look at the top view now, you'll see that the coordinate system jumped right into its spot. Everything was straightened up automatically. The box now is exactly aligned together with the part itself, and we're all set to go. We can go a little further down over here. Since we already have the pick Z level, I'm just going to pick my Z level on the top. Even though I don't have it, I could have left it at the automatic, but I like having things, if it's visible, why not make use of it? Okay. Now, let's go down to the part where I did not talk about before. I skipped over this, but now's the right time to talk about it, our actual rotation. If I want to modify now my rotation point, you'll note that we have a little bit of a pin at this area over here. Okay, you can see that pin over there. Now, what that pin means is that the coordinate system is pinned to the point. It'll turn exactly on the point where it's pinned to. Example, I'm going to go to my Z level and actually rotate it by 20 degrees. If I continue, you'll note that it stayed in its place and it rotated by 20 degrees. Now, on the machine, it's actually going to be more like this. Okay? That is how it's going to be lying on the machine. Because your machine, this is your X direction, and that's your Y direction. Okay? So this is how it's going to be on your machine. Now, if you have a probe on your machine, that's no problem. Because usually with the probes today, you can actually touch off even on an angle and touch off over here on an angle, and you can get that exact position. But normally to get that exact position, it's kind of hard. You need something straight over here, and you need something straight over here. And that would actually give you a point that's around over here. In other words, the box that you need will be more like this. So let's reset. I have a reset button here. Let's reset what I've done before. And this time I'm going to unpin this. And now when I turn it 20 degrees, look what happens. The box itself, the automatic box, also rotated itself, and now we have it exactly where we need it. Okay? So you have both options. You can either pin it or unpin it. Whichever is easier for you to work, that's the way you can work. Okay? I'm just going to just reset this for now. And I'm going to go accept what I did over here. Okay? I'm not even going to do anything over here. I can give it all the levels I need to. You know what? Why not? Let's give it a clearance level from the top of the part. And give it a delta offset of 20 millimeters. Give the top of the part can also be that same surface, which is not a problem. And again, the lower level will be at that point over there with a -6, just like I did before. And we have everything ready. Okay? Everything is perfectly ready. And, oh my God, I forgot to do something. I just realized that I have my coordinate system in this corner over here. And honestly, really, I'm probably going to have stock that's 2 millimeters over here and 2 millimeters over here, out. I wanted to do an offset. I wanted to actually give a delta offset from my X and Y direction. So I have to go back and edit. So let's go into edit. And remember, beforehand, when you edited something, you had to create it from scratch because it didn't remember anything that you've done. Let's go into our edit coordinate system. And we now remember everything that you've done in your coordinate system. All you have to do now is just go down to your levels and make the changes that you need. For example, the X, I'm going to have it at -2, and my Y is going to be at 2 millimeters. I'm going to accept that, and everything is moved over exactly the way I wanted it, without any problem at all. Okay, so now let's take a look at what we've done till now, and we're actually going to summarize. So we'll go back to my presentation. So let's summarize what we have done. We now have full associativity. Visibility is complete both on the part and in the selection fields. Editing the coordinate system location is exactly that. Edit and not create from scratch. These were just some of the highlights in SolidCAM 2022 in the new coordinate system. Thanks for joining me in this demonstration. Take care and have a great day.